adding and subtracting fractions. This is a lot more challenging than multiplying and dividing. All right, multiplying and dividing is very straightforward once you understand how to factor, because once you factor, you can just start canceling things, right? But adding and subtracting is a little bit more challenging. Why is it more challenging to add and subtract a fraction than it is to multiply them? Go ahead. Denominators have to be the same, right? If the denominators are the same, those are the kind of things that make me happy because I don't have to do any work. I can just multiply or add or subtract them and be done. If the denominators are not the same, this is where it created an issue when I was a child, right? Because now you had to find the greatest common factor. You had to multiply a bunch of things. Now you're multiplying fractions. Fractions are awful. Now things are bad. I'm sad, right? When the fractions are the same like they are in the first example, or sorry, the denominators are the same like they are in the first example. What is the number one mistake that I will see on this problem right here? They'll subtract 5 from 5. They will say that -3 minus 8 is -5, and then they will say that 5 minus 5 is 0. Please don't do that. If you're thinking of holding a pizza is cut into 8 slices, right? If you eat 3 of those pieces of pizza, you have eaten 3/8 of that pizza. That means if you're holding the box, there is 5/8 left. If someone takes one of those pieces of pizza, now we have 5/8 minus 1/8, which leaves us with 4/8. It does not leave us with 4 zeros, right? Please don't subtract at bottoms. I don't know what happens, but as soon as we get to algebra, when I start adding in x's and I start adding in x plus 2, x minus 5, whatever, as soon as I add those, people start to forget everything they know about fractions. Everything you know about fractions is still true. It just looks a little bit different. So just pay attention to this, that you do not subtract the denominators. Once you've subtracted everything, then we can simplify. Now, the hard part about this, that's different again than multiplication and division, is I was able to simplify with multiplication and division at the beginning. I'm not going to be able to do that here, okay? The simplification for addition and subtraction is going to have to take place at the end of the problem, okay? So it's always going to have to happen at the end. So it's going to get really tedious, and I'm telling you that right now. These problems are going to be a lot. There's going to be a lot of double distribution. There's going to be a lot of factoring. There's going to be a lot of redouble distribution. There's going to be a lot more factoring, and then there's going to be cancellations. Okay? It becomes very tedious. If we're doing the general form, if they're already the same, that makes it really happy for us because we don't have to do anything with them, so it's going to turn into A plus C over B. Right? You guys get if I turn both these off? Sure. Yeah. Does it make you happy or sad?
Makes me
have peace. All right. So then the next one, a little bit trickier because the denominators aren't the same, right? If the denominators aren't the same, we have to get them to be the same. What is the easiest way to get them to be the exact same? Multiplying by the other one, right? So if one is a 6 and one is a 5, I multiply the 1 by the 5 and the 1 by the 6, right? So I'm going to multiply this one by 6, and I'm going to multiply this one by 5, just because it's going to make my life easier. I don't actually have to go through and list the greatest common factors. Now, there are some times where it's really important that you think, right? You have to make sure you think. Like if I had something like 1 over 2 plus 3 over 6, what's the common denominator that I want to use of this one? 6. I don't want to use 12. I don't want to multiply the one on the left by 6 and the one on the right by 2. I can, but then that makes more simplification at the end. So use the least common denominator that you possibly can, and that will make your life a whole lot easier. So anyway, with this one, now here's our multiplication. 6 times 3 is 18. 6 times 5 is 30. Plus 5 times 5 is 25. 6 times 5 is 30. Add these together, I get 43 over 30. All right. One other thing that I see when people are finding common denominators is they only multiply the denominator. They don't do anything with the numerator. Just pay attention. If you are changing the denominator, you have to change the numerator, or else you've changed the entire fraction, right? If I have something like, again, if I was doing 1 over 2 plus 3 over 6, if I just multiply this one by 3 and turn it into 1/6 plus 3 over 6, I've changed that problem completely now, right? It's no longer 1/2 plus 1/2. It is now 1/6 plus 1/2, which is not okay. So if you're dealing with this, make sure that you multiply both the top and the bottom. Yes, I understand that I'm teaching you 4th grade stuff right now, but it's pretty important because people are going to forget this 4th grade stuff when they start dealing with algebra, okay? If you understand this in its basic form, it means you understand it in its algebraic form. We're just going to change the numbers, okay? So A over B plus C over D, I'm going to multiply this one by D over D and multiply this one by B over B. So it's going to become DA over DB plus CB over dB. And you can change it if you want. It doesn't matter if you call it BD or DB. Multiplication is commutative. You can move it around however you want to move it around. So now this will turn into dA plus CB over dB. Okay, should be pretty straightforward when you're dealing with these types of fractions. Things are going to get much more challenging when we start dealing with the algebra ones that you see on the page in front. Questions, issues, or concerns as you sit here at this moment? I'm probably not going to ever remember to say whining. I wish I did, because I think it's funny. I'd laugh every time I heard it. All right, so let's do these two. The first one I think is really easy, and I don't want to deal with the first one. You can figure out the first one pretty quickly. I hope it's like 7 plus 5 or something like that, right?
Can we just like take a second to go over?
The first one? Yes, 1,000. All right. One thing that I suggest is if you are dealing with subtraction, change the subtraction to addition, because then you're going to have addition problems the entire time. Okay? What I mean by that is if this is subtraction, change this to a plus sign, and then numerator only, make everything in the numerator opposite. Okay? So that means if I'm changing this to addition, I would change this to a negative, so then I would end up dealing with an addition problem with a negative numerator. Okay? It's going to be a lot easier in the future because all you're going to be doing is adding, and then you don't have to think about keeping a negative at all. So at the very beginning of the problem, change it from a negative sign to a plus sign, and then make everything in the numerator negative. Okay? So denominators are already the same here, right? So I'm going to end up with 2 plus negative 5, or 2x, plus negative 5 over x plus 6. Now, this example, it probably wasn't necessary for me to do that because I'm actually going to undo it now anyway, because plus negative is the same thing as subtraction. But the example that you see on the bottom right of your page, that's going to be really helpful for me to change that subtraction sign to a plus sign. Okay? So I'm going to get, oops, it's supposed to be a 5. So if I have this, a common mistake that I'm going to see, and I hate it when I see this so much, it actually makes me sad. Like, I see this and it actually makes my heart hurt for these people because I say it like 1,000 times to not do this in the middle of a class, but they still do it. I promise you, and I don't know if it'll be anyone in this class, but I promise you, people will cancel those, and then they'll say 2 minus 5 is negative 3, and then they'll say we have a 6 at the bottom, and then they're going to tell me that the answer is 1/2. Please don't. It doesn't make sense. So please don't do that if that's something that you think about. Yeah. So you cannot simplify this at all because we're adding and subtracting. We cannot change this. So we cannot do anything that I just wrote on the board. You need to leave it like that. That's your final answer. Okay? The one on the right, again, pretty straightforward. We have the same exact denominator, so I just add what's on top, 2x squared plus 2 over x squared plus 1. Now, this is where things are a little bit different than the last example, because what can I do to the numerator right now? I can factor out a what? A 2. So 2 showed up in both the top and in the bottom. Now, this is 100% different than the question that's in green. In the red, notice that I have an x squared plus 1 in both the top and in the bottom, and its multiplication. If that happens, you are absolutely allowed to cancel this and this because they are the exact same thing. X squared plus 1 and x squared plus 1 are the same, so I can cancel them, which is going to leave me with my final answer of 2. Right? Questions, issues, or concerns with these two? Now things are going to get more challenging. And the reason they're going to get more challenging is because I'm going to change the denominators so that they're not the same. Okay? But I'm going to try to work my way through it so that you understand what's going on. So let's look at this one.
Why didn't you do the one on the left?
Because I figured you could figure it out. Isn't it like 7 over 3x plus 5 over 3x?
It's 5 over 4x plus 7 over 4x.
Oh, it's close. So 12 over 4x equals 3 over x.
3 complicated.
There you go. There is your 1
You can
second.
simplify that one.
12 over 4 simplifies to 3 over 1.
3 over 1. Wait, what about the x?
It should stay there.
Yeah, this has to be.
It's still there. You're messing with me, right, Ashley? Yeah, okay. All right,
Yeah, this.
so the next one.
Yeah, I was definitely.
So, what I've got here is I have got an addition problem that has different denominators. Now that's an issue, right? I can't just add across the top and add across the bottom, which again is what I'm gonna see on Wednesday that people are gonna try to do. So don't make that U if it's U. We have to get the denominators to be the same first. The easiest way to do this is to factor as much as possible, okay? Now, most of the time, your numerator is already going to be factored, but if your numerator is not factored, leave it alone, okay? So leave your numerator alone in this spot right now. We are only dealing with denominators, okay? So as we look at this, I'm going to factor the denominator. Now, most people are not going to make this step, but I'm going to make this step so that you can see it. Instead of calling this 9x squared, I'm going to call it 3x times 3x. Because 9x squared is the exact same thing as 3x times 3x, okay? Now I'm going to add, and then it's going to be x over, and then what shows up in both of those?
3x.
3x. And then when I divide 3x squared by 3x, I get x, and when I divide 3x by 3x, I get 1. Okay? So now the question is going to end up being, what shows up in one of the fractions that does not show up in the other fraction? That's what we have to try and fix. Okay? We're going to try to fix this by putting things into the other fraction that show up in the fraction we're looking at. Okay? The first thing I like to do is I like to underline or circle or whatever shows up in both. You see how there's a 3x in both of those? That means I don't have to worry about that because they're already in both. I don't have to deal with them. Okay? Now, if I look at this one, there's an x plus 1 on the one on the right, right? If there's an x plus 1 on the one on the right, I have to put an x plus 1 on the one on the left. And in order to do this, I am going to multiply both the top and the bottom. So x plus 1 and x plus 1. Now, do these two denominators look exactly the same? Do they have the exact same stuff? Are they the exact same? Could I show you these and you say, yep, those are the same? Why are they not the same?
Because there's an extra 3x.
One of them has 2 3x's, right? One of them only has 1, one of them has 2. So if I want to fix this, I have to put another 3x over 3x in my problem. Now if you look at this, are they exactly the same? Are there 2 3x's and is there an x plus 1?
Yeah.
Hopefully. Okay? Now, here's another important part. Now that I've done this, I'm going to leave my denominators alone and I'm not going to touch them until the end of the problem. Okay? Don't do anything with the denominators until the end of the problem because what people are going to want to do is they're going to want to multiply all of this up. You can do that, but it's going to create way more work for you in the long run. So leave it alone. Don't touch it. Okay? So what you're going to do now is you're going to combine these into one fraction, which means that I'm going to have to distribute the tops so that I can combine like terms. So I'm going to multiply this out. 7 times x plus 1 is 7x plus 7. And then I'm going to leave my denominator alone. So I'm going to do 3x times 3x times x plus 1. Plus, and then I'm going to do the same exact thing on the other side. X times 3x is 3x squared. Over, and then I'm going to rewrite the denominator again. 3x times 3x times x plus 1. Okay, so just distributed, and now I'm ready to combine it into one fraction. In order to combine it into one fraction, I need to combine like terms of my numerator only. Leave the denominator alone. Just like we did in the other problems, do not touch the numerator because if you touch the numerator, the denominator, things are going to get really, really ugly. If I'm looking only at the top, there's only one x squared term, and that is 3x squared. There's only one x term, which is 7x, and there's only one constant term, which is 7. And now I have my one denominator, which is going to be 3x times 3x times x plus 1. Okay? Now here's the tedious part, as if it hasn't been tedious already. Now what we're going to do is refactor the numerator to see if anything will cancel. Now, this is a step where if you're strong at factoring, it's going to make it really easy. And if you're not strong at factoring, it's going to just make it tedious and tough. Because me personally, I don't have to write anything down to see if this factors. I'm going to use the Brooklyn method for this, which means I'm going to do 3 times 7, which is 21. I want two numbers that multiply to 21 and add to give me 7. So add to 21, or I'm sorry, multiply to 21 and add to give me 7. There's only two numbers that multiply to 21, 1 and 21, 3 and 7. Is there any way for me to add 1 and 21 or 3 and 7 together to get 7?
No.
Nope. So this can't factor, which is great. If it can't factor, that means that is going to be the exact same thing as this, and I don't have to worry about anything else. If you'd like to, if it would make you super happy, you can multiply all of the denominator out. You do not have to. Okay? You don't have to multiply out the denominator if you don't want to. You also still have to check what x can't equal. So in this problem, there's still x can't equal. What numbers are going to create issues in the denominators here? 0 and -1. Okay? So think about these problems as you work through these problems. Understand that it's basically a bunch of factoring and a bunch of combining like terms. The better you are at factoring, the better you are at combining like terms, the easier this process is going to be. Factoring just makes it a little bit of a more tough thing. More tough. So that is the answer, yes. So this is done. This is my answer. I could rewrite this again, but I don't want to because I'm lazy. So it's done. Right? So now, the next problem. This one's a little bit trickier. I'm going to have you guys attempt this. Okay? If you guys don't know how to do it, that's totally fine. But I'm going to have you guys give it a shot to see where you end up. If you do it great, that's amazing. If you don't do it great, that's okay, because we're going to try to fix it, and we're going to try to make it a little bit better. All right? So I want you to attempt this and see what you end up with. But before you do that, I'm just going to show you what I mean by making this thing a... Whoa. I'm just going to show you what I mean by making it a positive in the middle instead of keeping it a subtraction sign, because a subtraction sign is really easy to lose. Okay? So I'm going to change this minus sign to a plus. So I'm changing the minus sign to a plus, and then I'm going to distribute the negative into each of these. So since it was a minus sign, I'm changing it to a plus. This now becomes a plus, and this now becomes a plus. Okay? So now, give it a shot. Follow the steps that we just did. There are a few more steps in this one that we didn't deal with in the other one, and we'll get there when we get there. But I want you to at least see what you can do on your own. It's a bunch of factoring. That's what it is. All right.
For the
So,
final answer?
As we work our way through, first step is to factor. Don't touch the numerator, only touch the denominator. Numerator is going to be way, way tougher. Okay? Leave the numerator alone, only deal with the denominator. So I'm going to leave that alone. So x plus 2 over, and then completely factor the denominator. Everything. Everything that you can factor, factor it. I don't care how little it is. Okay? 2x minus 2, we can take a 2 out. So x minus 1 plus 2x plus 1 on the top, because I changed all those symbols because of the minus sign. And then the bottom will factor into, I need a positive 3 and a negative 4. So what two numbers will multiply to give me positive 3 and add to give me negative 4? Negative 1, negative 3. Okay? Now this is nice, and this happens more often than not, that something will show up in both fractions. That's the goal. Okay? So we can obviously see that x plus 1 already shows up in the bottom of these fractions. So that's great. What shows up in the left one that does not show up in the right one?
No.
2. So this number shows up here, it does not show up in the other one, so I'm going to multiply by a 2. Now, everything that's over here is over here, but that's not the same vice versa. So what shows up in the right one that does not show up in the left one? So now, are both denominators exactly the same? Yes. So now that both denominators are exactly the same, we're good. Now we can continue on like normal. But here's the tedious part. Okay?
Yeah.
That was the only new part of what we learned. Everything else past this point is going to be very quick and very easy. All right? Not quick and easy. Big like review, but tedious. Okay? It's the exact opposite. You guys keep looking out the door, and I'm pretty sure someone's standing out there.
There was some, all I can think about was drawing it off the orange.
Was it Darren?
No, it was Nicole.
My money would have been on Darren.
Oh, no, if it was him, I would have just hit him in the face.
Yikes.
No, he didn't do that.
Alright, so I'm gonna double distribute in the top. I'm gonna leave the denominator alone. I'm not going to touch the denominator at all because my goal is at the end of this to factor it again and simplify. So right now I'm not going to touch the denominator, only the numerator. So x times x is x squared. X times 2 is positive 2x. X times negative 3 is negative 3x. And negative 3 times positive 2 is negative 6. Over all of this stuff. And I'm just going to rewrite it. X minus 3 times x minus 1 plus double distribution again. 2 times 2x is 4x. 2 times 1 is 2 over 2 times x minus 3 times x minus 1. And now we combine our like terms. So we combine all the x squareds, we combine all the x's, we combine all of the constants. There is only one x squared term, so it's going to be x squared. Negative or positive 2 minus 3 plus 4. So 2, 3, and 4. So it's going to be 2 minus 3 is negative 1 plus 4 is positive 3x. And then the last one, we have our constants, negative 6 and positive 2, which is going to give me minus 4. All over my original denominator, which I still have not factored, still left it alone, have not done anything to it. Okay? Now, the last step, because we're still not there, this is why it's tedious, is we have to refactor. So factor the numerator again. So most of the time that you see these problems, the numerator is going to be able to be factored again. So what two numbers multiply to give me negative 4 and add to give me positive 3?
Negative 1,
Now, the reason that this exists or the reason that this happens most of the time is because something's going to cancel. Now, I do not want to cancel yet. What do I do before I cancel every time? Find what x cannot equal. So I'm going to look in the denominator of this fraction. The nice thing is there's only one place I have to look, and that's in the denominator. So x can't equal 3, and x can't equal positive 1. And now I cancel. So I cancel my x minus 1s. And my final answer is going to be x plus 4 over 2 times x minus 3. If you'd like to, you can distribute that 2 in the denominator. If you don't want to, you don't have to distribute that 2 in the denominator. So you can do that if you want. You don't have to if you don't want to. Right? Questions, concerns, or issues that you guys have that you would like to get cleared up? Yeah.
Where, like, how hard is this compared to like other ones that look up?
This is very consistent. So this would be about the level of difficulty that you would see on a test.
Oh, really?
But the thing is, so I want you guys to understand something. This is just an addition problem and a subtraction problem. If you flip over the paper that you're looking at, so flip over the paper and look at the very bottom, I also have the ability to change it into division. So as far as addition and subtraction goes, this is as challenging as addition and subtraction can really get. But the thing is, now we can change it to where I'm basically giving you 2 addition and subtraction problems and then making you multiply and divide them. Okay? So I could really do something to the point where it's just one question that takes you 15 minutes.
Can all the questions be like on the back side of the sheet, the middle top one?
I don't know what that question is, but I'm gonna go with no.
It's so challenging. Yeah.